All right, welcome. So in this lesson, we're going to continue on with our ideas that we've already gone through with square roots and, in fact, irrational square roots. And we're just going to extend that further to the next dimension. What about when we want to take a cube root of a number? So we're going to, today in this lesson, we're going to talk about cubes and what a cube root is. And then the skill we're going to go through is how to approximate a cube root. All right, let's look at the lesson. All right, so our learning objective is we will approximate cube roots. Now, the word approximate means that we are going to get as close to a value as possible rather than estimating, which is making our best or most reasonable guess of what a value is. So approximating, getting as close to as possible or as close as desired. And then the concept is a cube root, very similar to a square root, but now we're adding an extra dimension and we're going to be talking about a cube rather than a square. Okay, so our concept says a cube root is the value that when multiplied by itself 3 times, right? So 3 times here, different than a square root, gives us the value under the cube root symbol. Well, let's first slow down and make sure we understand the difference between a square root and a cube root symbol. A cube root symbol is exactly the same as the square root, only we add a little 3 in front of it. And it's a superscript. It's written higher and smaller. So this is the cube root symbol, not to be confused with the square root symbol, which we typically write without the 2. Let me go ahead and erase this so we're not confused. The cube root symbol, again, is just like a square root symbol, only we add the little 3 here to let us know we're talking about a cube root. So if a cube root is the value that when multiplied by itself 3 times, gives us the value under the cube root symbol. Let's kind of break that down here. I'm going to color code this a little bit because it can be confusing. A cube root is the value, that one's going to be in blue, that when multiplied by itself 3 times is equal to the number under the cube root symbol. So when I say the number under the cube root symbol, I'm talking about this 27 right here. That's under the cube root symbol. Now, what is the cube root of 27? Well, it's 3. That would be the value that when multiplied by itself 3 times gives us that original 27. So again, this is very similar to a square root, only now we're looking for a number times itself 3 times that gives us the number under the cube root. Now, it's very helpful to think about this geometrically also. So I have an example here where I have an actual cube, a 3-dimensional object. Now, the volume of a cube is this formula right down here. Volume equals length times width times height. That's how we calculate a volume. And volume is the space inside or how much a volume, how much space an object takes up. Now, what if I wanted to find one of the lengths of a cube? Well, if I know the volume, let's say the volume is 27 inches cubed. If I wanted to find one of the lengths, I would take the cube root of that volume in order to find it. So it's very helpful to think about a cube root and a cube as being inverse or backwards from each other. So one more time, a cube root is when I have a number multiplied by itself 3 times gives us the number under the radical symbol. Now, we have perfect cubes and we also have irrational cubes. So let's look at an irrational cube because that is what we're going to be talking about in our approximating in our skill. So down here we have an example of an irrational cube root. So the cube root of 45 doesn't have a nice number that when I multiply it by itself 1, 2, 3 times gives me 45. There is no whole number multiplied by itself 3 times that gives 45. So therefore it has to be an irrational decimal. So here you can see I've got 3.556 and I'm multiplying that times itself 3 times. And if I do that, it actually gives me 45. So the cube root of 45 would be this irrational decimal right here. Now, one more thing to note is this symbol right here. What I'm using is the approximately equal to symbol because an irrational cube root, we can only approximate it, which is the actual skill of the lesson. We're going to be coming up with this 3.556 decimal, only don't worry, I'm only going to make you do it to the 10th. So let's go to the skill. Okay, so to approximate, right, come up with the as close of a value as we can, or the closest of a value as desired of a cube root, these are the steps we're going to go through. So this problem says approximate the cube root of 18 to the nearest tenth. So I need to go at least to one decimal place. Now, the steps are very, very similar to approximating square roots. I need to find the two perfect squares on either side of this cube root of 18. So I have some perfect square cubes over here. The cube root of 18, I see, would fall right here in between the cube root of 8 and the cube root of 27. So the cube root of 18 falls right in between the cube root of 8 and cube root of 27. Very similar to finding square roots. So let's go ahead and write that over here and show you what it should look like. Cube root of 8 is less than the cube root of 18, which is again less than the cube root of 27. Now, the reason why we need to find the cube roots, the perfect cubes that square root of 18 falls between, the cube root of 18 falls between, is because we know those values. We know that the cube root of 8 is simply 2, because 2 times 2 times 2 is 8. I also know that the cube root of 27 is 3, because 3 times 3 is 27. What that tells me is that the cube root of 18 has to be less than 3, but greater than 2. So I need to guess a decimal that is less than 3, but greater than 2. So I'm going to start with my first guess being 2 points, well, let's see. 18 is how far away from 8? It's about 10 away from 8. The difference between 8 and 18 is 10. And the difference between 18 and 27 is 9. So it has a smaller difference. So I'm going to go ahead and write a little note to myself right here. The difference between these two is 9 and these two is 10, which means I should guess a decimal that is closer to 3. So now it's very close to both 8 and 27. So I'm going to guess, you know what, I'm going to guess 2.5 is my first guess. 2.5 is my first estimate. Now, it's an estimate because I'm making a guess. Now, let's see how good my estimate is. The way I do that is I'm simply going to cube 2.5. So let's try that over here. 2.5 cubed, which would be 2.5 times 2.5 times 2.5, I can actually do with my calculator. Now, of course, we could do this by hand, but I'm not asking you to do this with your by hand. Don't multiply all that out. Use a calculator for this. The real point of the lesson is not the multiplication. It's actually the skill of approximating. Now, to begin with, I'm going to do 2.5. And if you have a smartphone like an iPhone, you can actually find the cube button, which would be x cubed, x to the third power, and it'll do it very quickly for me. And I get that the 2.5 cubed is 15.625. Okay, well, 15.625 is actually a little bit under 18. So my guess was not very close. So I have to guess again. So this is me now doing step 4. I need to actually try again and get closer. So if 2.5 wasn't close enough, now I need to guess a higher decimal. I'm just going to guess 2.6. All right, so let's see. My next guess is going to be 2.6, which is also greater than 2 but less than 3. So let's try cubing 2.6. All right, well, when I cube 2.6, I've got that right here. It is 17.576. 17.576. Okay, now this is much closer to 18. In fact, this is probably going to be my approximation to the nearest tenth. But this is an important thing to note. Whenever you're doing an approximation, you have to always find one estimate that is below the number and one that is above it in order to see which one of those actually is closer. So right now I have two estimates that are below 18. I have to go with a third guess that puts me above it. This is actually how we get closer and closer to our approximation. We go over, under, until we can get close as possible. So my last guess here is going to be 2.7, because that is again less than 3 and greater than 2. So let's do the cube of 2.7, and that one gives me 19.685. 19.683. Let me clean that up a little bit. 19.683. And now my final job to do here is determine which one of these two is closer, the 2.6, which gives me 17.56, or the 2.7, which is 19.683. Now, you're not looking for one that's over or under. That's not what we're looking for. We're looking for whatever one is closer to 18. So 17.576, that's only roughly 0.5. It's 0.424 away. And my 19, the difference between that and 18 is going to be 1.68. That one is definitely farther away. So my correct estimate is right here in the middle, this 2.6. So what I'm going to now finish with is write down what is the approximation of cube root of 18. So I'll write the cube root of 18 is approximately equal to, so not two straight lines, which is equal to, approximately the wavy lines, is equal to 2.6. All right, thank you for watching.